Mary is 10 miles from her home. She is returning home walking at a constant speed of 2 miles per hour. Her distance from home can be modeled as a function of time. Graph Mary's distance from home as a function of time on the grid below. Making lines or line segments use a straight edge. Okay, so this is a distance versus time graph, and it says that she starts 10 miles from home, so her distance from home at time 0 at the start is 10 miles. And then it also tells us that every hour she walks 2 miles. She must be walking very slow. She's probably looking at her phone. Which direction, though, is she going to go? Is she going up on the graph or down on the graph? Well, it says she's walking towards home, right? And where is home? Home is down here at distance 0, right? If she's at home, then her distance from home would be 0. So after 1 hour, if she walks another 2 miles, she'd be 8 miles from home. And then she'd be another hour, she'd be 6 miles from home, and then 4 miles from home, and then 2 miles from home, and then she'd get home there. Okay. Now, it's very important that we don't just leave this like this, because what this graph suggests, there's only points here. This graph suggests that at time 0 she was 10 miles from home, and then she wasn't anywhere to be found. Until 1 hour later, all of a sudden, she appeared 8 miles from home, and then she wasn't anywhere to be found. No, what's really happening is that she's walking along, and so we need to show all these other points where she is, even though they're not whole numbers. She was still at those places. For instance, after half an hour, she was 9 miles from home, right? And in between, she was somewhere, right? She was walking step by step. So this graph needs to be a continuous graph. You can't just put the points on there.